programming languages typically support a set of operators, constructs which behave generally like functions, but which differ syntactically or semantically from usual functions. Common simple examples include arithmetic and logical operations. More involved examples include assignment, field access in a record or object, and the scope resolution operator. Languages usually define a set of built-in operators, and in some cases allow user-defined operators. Syntax: syntactically operators usually contrast to functions. In most languages, functions may be seen as a special form of prefix operator with fixed precedence level and associativity, often with compulsory parentheses, for example func. A, in Lisp. Most languages support programmer-defined functions, but cannot really claim to support programmer-defined operators, unless they have more than prefix notation and more than a single precedence level. Semantically operators can be seen as special form of function with different calling notation and a limited number of parameters. The position of the operator with respect to its operands may be prefix, infix or postfix, and the syntax of an expression involving an operator depends on its arity, precedence, and associativity. Most programming languages support binary operators and a few unary operators, with a few supporting more operands, such as the operator in C, which is ternary. Commonly, unary operations are prefix, such as unary -x, or occasionally postfix, such as post-increment x++. And binary operations are infix, such as x plus y or x equals y. Infix operations of higher arity require additional symbols, such as the ternary operator. In C, written as A, B, C A euro. Indeed, this is the only common example, it is often referred to as the ternary operator. Prefix and postfix operations can easily support any desired arity, however, such as 1 2 3 4 plus. Occasionally parts of a language may be described as matchfix, or circumfix operators, either to simplify the language's description or implementation. A circumfix operator consists of two or more parts which enclose its operands. Circumfix operators have the highest precedence, with their contents being evaluated and the resulting value used in the surrounding expression. The most familiar circumfix operator are the parentheses mentioned above, used to indicate which parts of an expression are to be evaluated before others. Another example from physics is the inner product notation of Dirac's Bra-Euroket notation. Circumfix operators are especially useful to denote operations that involve many or varying numbers of operands. The specification of a language will specify the syntax, the operators it supports, while languages such as Prolog that support programmer-defined operators require that the syntax be defined by the programmer. Semantics: the semantics of operators particularly depends on value, evaluation strategy, and argument passing mode. Simply, an expression involving an operator is evaluated in some way, and the resulting value may be just a value, or may be an object allowing assignment. In simple cases this is identical to usual function calls. For example, addition x plus y is generally equivalent to a function call add x, y, and less than comparison x for greater than, with names often outside the language's set of identifiers for functions, and called with a syntax different from the language's syntax for calling functions. As a function, greater than would generally be named by an identifier, such as gt, or greater than and called as a function, as gt, x, y. Instead, the operation uses the special character, and infix notation, as x, y. Common examples that differ semantically are Boolean operations, which frequently features short-circuit evaluation, for example a short-circuiting conjunction that only evaluates later arguments if earlier ones are not false, in a language with strict call-by-value functions. This behaves instead similarly to if else. Less common operators include, comma operator, e, f, dereference operator, p and address of operator, and x, Elvis operator, x, y, null coalescing operator, x, y, spaceship operator, xy. Compilation: a compiler can implement operators and functions with subroutine calls or with inline code. Some built-in operators supported by a language have a direct mapping to a small number of instructions commonly found on central processing units, though others may have complicated implementations. Operator overloading. In some programming languages an operator may be ad hoc polymorphic, that is, have definitions for more than one kind of data. Such an operator is said to be overloaded. In languages that support operator overloading by the programmer but of a limited set of operators, operator overloading is often used to define customized uses for operators. In the example if order date 122/2011, and order date, and